Okay, last part of this question, and some of the difficulty here is interpretation. They give us same thing as the previous problem, so same differential equation. We've solved for gamma, it is 2000 root 3. This will give us a critically damped scenario. And then they tell us at t equals 0, before that the car was not moving up and down, but then it hits a bump, and it's going to add 1, it actually says 1.0 meters per second to the vertical component of the speed. And they want you to find the maximum position above the equilibrium. Okay, so we have to interpret all this. This one for sure says that y prime of 0 equals 1. Right, because we were not moving up and down before, so y prime was 0 before, and then suddenly we have a bump and it makes it jump up to 1. We have to interpret this one, which kind of makes sense, to say y of 0 equals 0. It wasn't moving up and down before. The bump made us change speeds, and then it'll change position according to how it changed speed. So that's a little strange. And then finding the max position, meaning the max value of y of t in the whole span of time forever. How do we do this? Well, this is a continuous function, so we think back to Calculus 1, and we say that this is optimization, meaning that for t value where y prime of t equals 0. Right, that's going to be that horizontal tangent thing where you have a maximum, so the derivative should be 0. Okay, how do we do this? First, we've got to solve this differential equation, and luckily we have some work from before that we can use. We already had the characteristic equation, and we already know that we found the gamma that made this thing 0. So really, we can just use this r, where this part is 0, gamma is 2000 root 3, so it's negative 2000 root 3 over 3000, which is going to be negative 2 over root 3. And this is going to be a repeated root. Okay, so we can skip most of the calculations to do with this. We can just go right to a repeated root, so the general solution is going to be a, e to the root was negative 2 over root 3 t plus b t e to the negative 2 over root 3 t. That was the repeated root. Okay, great. Then we need to solve for a and b via the initial conditions. So y of 0, we're going to put in 0 for t. This part will be 0 because we're multiplying by t, so that's going to be a, which is 0. Okay, great. So that really means we can sub this in right here and make our solution easier. A is 0, so this is just bt e to the negative 2 over root 3 t. And then we need to use the other initial condition, which is y prime. So we need to take a derivative. Y prime of t is, using the product rule, derivative of t is 1, e to the negative 2 over root 3 t, minus, because we have a chain rule, so that exponent is going to come down, b t e to the negative 2 over root 3 t. Okay, and then we know y prime of 0 is 1. So we have y prime of 0. Putting in 0, this part will be 0, so we get b equals 1. Okay, this was easy. We have easy constants. So y of t is now just t e to the negative 2 over root 3 t. And we'll put b into y prime of t as well. Y prime of t is e to the negative 2 over root 3 t minus 2 over root 3 t e to the negative 2 over root 3 t. We're going to set this equal to 0. Let's do this on the next line actually. Set y prime of t equal to 0. We'll actually do this on the next page. While we do that, we're going to factor out an e to the negative 2 over root 3 t. And so we'll be left with 1 minus 2 over root 3 t equals 0. We're setting this thing to 0 while factoring out e to the negative 2 over root 3t. Then we have e to a power. This part's not going to be 0, so this part has to be 0. So 1 minus 2 over root 3t is 0, which means we solve and get t equals root 3 over 2. That is the t value where y prime of t equals 0. So now we just got to find y of t at that value, y of root 3 over 2. Remember, y of t is t times e to the negative 2 over root 3t. So if we put in root 3 over 2 up here, this is e to the negative 1, and we have a t down here. So we have root 3 over 2 times e to the negative 1. Put that into WebAssign in whatever decimal format they want.